What is up, VCE Method students? Today we're going to go through some integration rules. Integration rules is nothing that you have to memorize. It's all on the formula sheet, but with practice, you're just going to memorize them anyway, and you're just going to get used to them and just, remember the rules and make it faster for yourself. We don't want to always go through the formula sheet whenever we're, solving equations and, solving these honestly basic questions when you get to your final exam, but they are there for reassurance anyway. So just know that you don't have to necessarily memorize them, but with a lot of practice, we're aiming to be, top 10%, top 5%, even top 1% student, you're going to eventually memorize them anyway. So let's get started. And you'll notice that all of these rules are pretty much the backwards of differentiation anyway, because as I've reiterated in previous videos, integration is just the opposite of differentiation. So for example, we have this power rule here. So you can see that x to the power of n becomes where you add 1 to the power and divide by that new power. If you think about the differentiation rule, you multiply down by the power and you minus 1 from the power. So you can see this is just the opposite thing in the opposite order. I'm just going to quickly describe to you how the notation for integration works. So you have this squiggly line here. So this is kind of like the integral operator. So whenever you see this, we're finding an integral. So in this case, how we read this is the integral of x to the power of n with respect to x. So dx just denotes what the independent variable is that you're integrating with respect to. It's very similar to the d over dx for differentiation. So the integral of x to the power of n with respect to x. So you can see, as I said before, you add 1 to the power and you divide down by that new power. The only addition is the plus c here. And again, these are just the general rules, so that's why we include the plus c. And as I said in previous videos, if you have an extra piece of information, such as a coordinate that lies on your function, then you can substitute in that value and you can find the specific c value for that case. In these cases, we don't have an individual point, but if you were given one, then you'll just substitute it in to find the c value. So let's try and evaluate this one. We have the integral of x squared plus 2x cubed dx. Now, very similar to differentiation, if you have two individual functions added together, then we just find the integral of them respectively and then add the two integrals together. It's not too complicated. So in this case, we have x squared. So if we want to integrate that, what do? We add 1 to the power, we divide by that new power. So this one is going to become x cubed over 3. Now for 2x cubed, we add 1 to the power, so it becomes 2x to the power of 4. Then we divide by that new power, so this will become 2x to the power of 4 over 4 plus c. The only difference we have in this case is we have to simplify this one, so that will become x to the power of 4 over 2, and that's going to be our final answer. Now, here we have a different type of rule. This one is just a normal power rule. This is a very specific rule. And the reason why we have a very specific rule is because integration is more complicated than differentiation from a calculus and an algebra standpoint. So you might actually notice that this is very similar to the chain rule. This is just the backwards of the chain rule, but the chain rule in a specific case where you have something linear raised to a power. We actually don't have a general chain rule that we learn in VCE methods. We just have this specific case because it's a bit more basic and it's easy to apply the formula. But for other things in chain rule, let's say if you have just a function inside another function, let's say you have log base e of cos of x, there's no general rule for that. That's really easy to implement in VCE methods. So it's actually reserved for later maths. Let's say if you're doing engineering in university, you'll learn about your general types of chain rule and that type of thing. In this case, we don't worry about it. We just have a specific rule for this specific case that is a bit more common in VCE methods compared to other cases where you just don't need to know it. So in this case, we have ax plus b to the power of n. If we want to integrate that, what you do is you divide by the coefficient of x. So you can see that's a there, divide by the new power, which is n plus 1, and then you just have ax plus b raised to a new power. And it's exactly the same for all the other integration rules. If you differentiate this function, you're going to get your original function back. So that's a good way of double checking when you're first learning integration. It's that you can just reverse the process and you can get the original function back. And it's a really good way of double checking if you've done things right. So in this case, we have the integral of 2x minus 1 to the power of 5. So if we just apply this formula, we have 1 over the coefficient of x, which is 2, and then 5 plus 1, which is 6. Then our bracket remains the same, and the only thing that changes with our power is we just add 1. So this one just become 1 over 2 times 6, which is 1 over 12. And that's pretty straightforward there. Okay, so for this rule here that we discussed before, this actually works for most cases. It works actually for all cases except n is equal to -1. And there's a couple of reasons for that. One of the main reasons is that if n is equal to -1, you can see that we divide by 0 because -1 plus 1 will equal 0. And you can see also if we have -1 there and then you have a new power, the power is going to equal 0, which doesn't make sense. The power equals 0 after you add 1 to make the new power. So if n is equal to -1, we actually have a specific case, and you might notice here that I've kind of emphasized this, n is not equal to -1. So this works for all n values except -1. So when n does equal -1, we actually have a separate case altogether that is separate on the formula sheet as well. And you can see when n is equal to -1, this can actually be simplified to 1 over ax plus b, because whenever you have a negative power, you can bring it at the bottom. So it's going to be 1 over ax plus b to the power of 1. And obviously the power of 1 doesn't make a difference algebraically. So what you actually do in this case is you memorize a new rule, and this new rule is 1 over a log base e of ax plus b plus c. Now, if you look at the formula sheet, depending on which formula sheet version you're looking at, and depending on what textbook you use in class as well, your formula sheet might actually split this into two equations. And the reason why it splits it into two equations is because ax plus b can't actually be negative. And that's because you can't have negative values inside your log bracket. So there's two ways of overcoming this issue. The first way is to split this up into two formulas. So let's say if ax plus b is greater than 0, then this formula is fine. But let's say if ax plus b is negative, let's say you're on the negative portion of your hyperbola, what you actually do is you say 1 over a log base e of negative ax plus b plus c. And we use this formula when ax plus b is less than 0, because what's going to happen is this is negative when ax plus b is less than 0, and then the negative at the front makes that negative positive because of the double negative property of it. Therefore, this bracket in total will be positive and the log can be calculated. Now, this is not the most ideal way of doing this formula. What I'm actually going to do is get my eraser and fix this up, because I don't like memorizing two equations, Memorizing two equations is a bit of a pain, okay? And I don't like to do more work than is required. So what I'm doing, sorry, this whiteboard marker is very persistent. What I'm doing is I'm making it easier for myself. I'm going to include these straight brackets here. You might not have seen it. You'll notice this, you kind of memorize this or find this familiar if you did spec. What this is a modulus bracket. So what a modulus bracket does is if the number inside it or the expression inside it is negative, it makes it positive. And if it's positive, it just stays the same. And this is very useful for log equations because you can only have positive values inside. So let's just do a basic example. If you have the modulus, so this is the modulus of -2. Again, it's just straight brackets. Modulus of -2 becomes 2. But the modulus of 3 will stay 3 because it's already positive. And again, this is very useful because let's say if this ax plus b expression is negative, it makes it positive and it makes the log actually useful and calculatable, okay? And if it's positive, it'll remain the same, so this is fine. This works for all cases of ax plus b, and you don't have to worry about memorizing two different equations. Now, just to let you know, these aren't all the equations that you have to use and memorize in integration for VCE methods. There's a whole list of them. It's not that long, but you'll notice that the list is actually smaller than the differentiation list. And the reason for that is because integration is more complex than differentiation, as I mentioned before. So therefore, there's less formulas that you actually have to memorize. So for example, you don't have to know the integral of log. You don't have to know the integral of tan, and there's no rules for chain rule, product rule, or quotient rule. And I mean, the only exception to that is this specific case of chain rule that's easier to calculate. There's no chain rule, there's no product rule, there's no quotient rule in general in VCE methods. So there's less formulas that you have to memorize, and obviously it makes it a lot easier when you've done differentiation before because the formulas are directly linked, because it's just the opposite of the differentiation formulas as well.